Welcome to my YouTube channel Learn with Joy, and this is a video lecture series on computational mathematics. In this series I would like to discuss some applied mathematical tools, concepts, theories which are mainly used for the purpose of computing. Rather we may say modern computing, that is the computing and the algorithm developed day after day is a very good application of modern computational theory. Now first I would like to discuss about optimization theory. This is the most interesting topic in our real life phenomenon as well as computational mathematics. Now what is it? Optimization is a process of finding the best value or solution from the solution space, that is feasible solution. Theoretically, if we discuss, it is required for each and everyone in their daily life. Several persons are doing this kind of activities in their daily life, like a carpenter wants to minimize the number of wood logs for preparing some desk. House developer wants to maximize the profit, and there are several examples. If I want to say that a salesperson of e-commerce wants to minimize the distance to cover all destinations for supply. This is a well-known problem of traveling salesperson problem. We will discuss it more thoroughly later on. Now if I combine that, if the minimization and maximization both terms are related to a particular problem, that is, if we discuss that a business or agent wants to minimize the cost involvement and maximize the profit, thus the optimization means maximization or minimization with respect to the corresponding phenomenon. That is, in a particular phenomenon, one objective may be minimized, and on other particular phenomenon objective may be maximized, and both are used for a particular objective function. That is, depending on the goal and mathematical formulation, the optimization may be minimization, if we give example, that is cost, or the maximization as profit. And in our modern optimization theory, both are combined and then it can be solved. Now if we brief again, in mathematics, computer science and economics, an optimization problem is the problem of finding the best solution from all feasible solutions. That is, the application area of optimization is very wide, because it is applicable for financial part, it is applicable for economics, it is very much applicable for the problem of e-commerce, and there are so many application area for the optimization. Now I want to brief some historical background. George Bernard Dantig, a US mathematician, and Leonid Kantorovich, a Russian mathematician, and our well-known John von Neumann, a Hungarian American mathematician, computer scientist. As we know, the Neumann architecture is the first modern computer science architecture, are called the pioneer of modern optimization technique. This technique, the series of techniques rather invented around 1939 to 42 during the World War II. Invention started with linear programming problem, simplex methods, as well as duality, etc. And thereafter the modern optimization uh, problem description algorithm invented is going on. However, if we say that they three persons are the pioneer of modern optimization technique, then what other honorable persons uh, how did in their life and how contributed in our real world. Now I must say Euclid book 3 and 4 also described the minimization and maximization, and Isaac Newton, we do not say it more elaborately, because Newton's theory and application are being used today also. There are several optimization tools invented by Newton. What I will say, rather I may say that Newton-Raphson method for finding the root, which is a very popular, then quasi-Newton method. And if we describe so many algorithms, then we must say that Newton is a contributor of the maximization, minimization, and rather optimization problems. And Lagrange have also contributed so many tools, mathematical formulas for optimization techniques. If I cite an example, that is the Taylor series. Taylor series is a base of many mathematical theory and formulas. Taylor series in the form of Lagrange remainder, then the Lagrange name itself appears here. For finding maxima minima, Taylor series is a very much important, and all are the creator of art of finding the best. That is what we are discussing, the optimization. Now a mathematical optimization. Why mathematical optimization? Because if I describe it rather like, in a simple case, the decision or outcome or the goal may be achieved by human perception. If it is the simplest case, that it will be calculated by the human perception or some simple calculations itself. But in present real life, this referred process, that is the mathematical that is the optimization process, is not so simple. There may be so much constraints. There may be the some more complex objective function, etc. Therefore the mathematical optimization comes out. Now in this section I want to describe the optimization process in a just nutshell, just a brief idea about the optimization process. In defining, we want to say that it is a sequence of process. Firstly, to formulate a concrete mathematical model with the exception of a few scenarios that the concrete mathematical model is not required, but in the 90% cases, firstly we have to formulate the concrete mathematical model in which there may be a set of objective functions from which we have to find out our requisite optimum value, that is requisite minimum value or maximum value, and it may be restricted by constraints. It is not mandatory that it is to be restricted by some constraints. In that case, the process is called constraint optimization problem. Otherwise it will be called unconstraint optimization problem. Therefore suitable steps thereafter suitable steps or algorithms to be followed to find out the optimal value. Once I have completed the mathematical formulation of our problem, then there may be several methods, several algorithms to be followed to find out the optimal value. It may be our traditional iterative methods, it may be a linear programming problem as per the linearity of the problem, it may be integer programming problem, it may be multi-objective optimization problem, which is being discussed, as well as achievement is growing on day after day, multi-objective optimization problem. And the algorithm may be deterministic, may be stochastic, and it may be heuristic or meta-heuristic. That is, in contrast to our traditional iterative mathematical methods, there are several very latest evolutionary algorithm method, which is also to be discussed at the part of meta-heuristics methods to finding the solution. Now for discussing the optimization methods, some prerequisite concepts are required. That is, although we have started from the concept of matrix, we should have the concept of set theory, some geometric concepts, algebra, etc. Then concept of matrix is very much required. Concept of vector algebra, vector analysis, as well as vector space. That is, we have to be calculated some eigenvalues and properties. Those are related to matrix and vector algebra. Now derivatives, concept and applications. The derivative, single order, higher order derivative, partial derivative, and etc. and its application. Like we have started our reading with minimization or maximization, whatever, and then the derivatives calculations are required for calculating for minimization or maximization, finding the minimum value, maximum value, for finding the saddle point of inflection, etc. And then the concept of algorithm. This topic algorithm is not bounded. That is, there are several algorithms, and our ongoing and upcoming algorithms are there, so many. That is single objective, multi-objective, NSGA, vector, etc. and evolutionary algorithm, genetic algorithm included, heuristic, meta-heuristic, and etc. There are so many. So as far as we can move, as far as we can discuss, we will discuss it. Now directly we want to describe how to formulate an optimization problem. The similar thing we have seen if we have some idea about the linear programming problem, through which we have started our operation research optimization problem. We may be familiar with this, but in this case we will discuss the generalized idea about the mathematical formulation of optimization problem. Now, in general, it is possible to write most optimization problem in the general form mathematically. That is minimize f(ix), where the vector x belongs to the n-dimensional vector space R, that is real value. and here if ix I equals 1 to up to m, say, subject to phi jx equals 0, j equals 1 to up to say capital J, and then psi k x, this bold x's are considered as the vectors, this is less than or equal to 0. It this may be formulated as greater than or equal to 0 if the problem is maximized, or it may be less than or equal to 0, greater than or equal to 0 for the minimization problems, and for which we have to convert our concern form, respective form. Here k equals 1 to up to k. Where f ix, phi jx and psi kx are functions of the design vector. This is called objective function, and these three are also called design vectors, where the vector x itself is described as x1, x2, these are scalars, xn, that is in nth, here it is n column vector, as we have transposed it as a whole. This is the notation for transpose. Here the components of xi of the x vector are called the design vector or decision variables, and they can be real, continuous, discrete, or mixture of these two. The function f(ix) where I equals 1 to m are called the objective functions, and in case of m equals to 1, that is if it is like f1x, it is called single objective optimization problem, and if there are more than one values of I, then it is to be called multi-objective optimization problem. The objective function is sometimes called the cost function, loss function, maybe profit function, or energy function in literature, in different area of application, that is in economics, in business, in mathematics. We are describing it like, if there are no constraints, that is if j equals 0 and k equals 0, if j equals 0 and k equals 0, that is if 0, and we say that these are not appeared at all, then the problem becomes unconstrained optimization problem. Okay. Now there may be two other scenarios, that if both are equals, if j greater than or equal to y but k equals 0, it becomes equality constraint optimization. That is, if k equals 0, then it is equality optimization problem, that is no less than or equal to will be here. Conversely, if j equals 0, k greater than or equals 0, that is the equality will be striked out, and here this is less than, then the problem is to be called, it becomes the inequality constraint problem. This is the as a whole mathematical formulation of our optimization problem. Now uh, we will discuss some categories of optimization problem. We may categorize the optimization problem into several kinds, and it may be situation that we cannot fit in a single window. There are several aspects, several dimensions for categorizing the optimization problem. Like say, for if I say that with respect to the constraint of the optimization problem, the problem may be categorized into two broad portions, that is constraint optimization problem and unconstrained optimization problem. We have discussed these earlier. And if there are number of objective function wise category we want to categorize the optimization problem, then it may be single objective optimization problem, as well as it may be multi-objective optimization problem. And if we discuss with another point of view, it may be deterministic. The optimization problem may be categorized into two broad categories, that is deterministic and stochastic. What is deterministic? That is specific causes produce specific effects. In our deterministic problems, specific causes produce specific effects. And stochastic means it involves randomness. It is somehow probabilistic. Okay, and after that, if we categorize with respect to algorithmic approach, it may be categorized into two broad categories, although these categories are not complete to discuss our optimization problem categorization, because it has many subcategories, many algorithms are involved with this. Now broadly I may describe that the optimization problem may be traditional iterative method algorithmic or evolutionary algorithm. Okay, now the optimization problem may be categorized with respect to the linearity of the problem, that is it may be linear, that is objective functions are linear, non-linear or specialized. This is some nutshell idea or brief idea about how to categorize our optimization problem with respect to few certain parameters. So I would like to acknowledge the books and resources, and I would like to refer it for your further study and reference, as because the optimization problem is a very growing topic under the applied mathematics as well as the computational mathematics, modern computing era or phenomenon. There are few good books. Okay, now what about me? I am Supratim Chakraborty. I have received MCA NOC DBA professional qualifications, and I have also completed Aprit Swayam course for data analysis for social science teacher, soft computing, which is a under online course Swayam NPTEL IIT Kharagpur, as well as I have received machine learning certification from Tata Steel. Okay, thank you so much. Bye.